All right, Geology 105 students. It's Dr. Mark Tinsley, and we are continuing in our remote learning environment. I appreciate everybody hanging in there. I know this is not ideal. I know it's hard to learn geology this way, but you hang in there because we're going to get through this together, and on the other side of this, we'll be the better for it. All right, so today we want to talk about mass wasting, and let's jump right in. Why wait, right? What is mass wasting? Well, mass wasting is simply the downslope movement of Earth material under the influence of gravity. Things that roll down, flow down, whatever hill, downslope, under the influence of gravity, that is mass wasting. This principally involves soil matter, which is the byproduct of weathering and erosion. Now, we haven't talked about the formation of soil in this class, but you know what soil is, and this is principally what mass wastes, what moves downhill under the influence of gravity. Stream erosion and mass wasting work together to create and widen stream valleys and lower the elevation of the land surface, as we've talked about, I think, last week during streams. Mass wasting can occur anywhere from shallow to steep slopes, so it doesn't have to just be steep slopes, even shallow slopes mass waste. And dramatic examples of mass wasting occur in mountainous areas and young stream valleys because these are steepened environments. And so we'll see some pictures of that here today. What are the factors related to mass wasting? There are three major factors related to mass wasting. Number one is water. Water adds weight to soil or earth material and also decreases the cohesion or friction between the earth particles. So if I'm adding more weight to the soil or rock material and I'm decreasing the friction between those particles, I am going to encourage that material to slip and slide down slope. Okay, so water is a big factor in mass waste. Increase the water, you increase the potential of a material to mass waste. Secondly is the angle of repose. Now, the angle of repose is the angle at which a slope is stable. This angle depends on the type of earth material. So, when a material at or below the angle of repose, a slope is stable. Let me go to the next slide so you can see the angle of repose. So if we have an imaginary horizontal line, the angle of repose is the angle from that horizontal line down to the slope of the slope, right? So you see that in our example, the angle of repose. As that angle decreases, the potential for sliding or mass wasting decreases. As that angle increases, the potential for mass wasting increases. And you can see why that is because as that angle increases, you're increasing the slope of the soil or earth material. All right, so angle of repose. The size and shape of so what controls the angle of repose? The size and shape of the particles and the water content affect it, first of all. Larger particles, more angular particles, tend to pile up at higher angles of repose and remain stable, whereas softer or smaller materials or rounder materials typically have more shallow angles of repose. As water is added to a slope, the angle of repose decreases, right? And that's basically what I've said in the next two bullet statements. Okay. Once the angle of repose is exceeded, the slope is considered oversteepened, and oversteepened slopes typically slide. Okay. Third factor related to mass wasting is vegetation, because vegetation, the roots of vegetation typically stabilize slopes. That's why you'll see when new slopes are cut, like roads are cut through, those slopes will be immediately planted with grasses and weeds and things of that nature to try to, they want to get those root systems in there to hold those slopes in place so they don't slide. And again, there's our angle of repose. What are the triggers of mass wasting? What gets mass wasting going? Earthquakes can trigger mass wasting. It shakes the ground, stuff gets shaken up and starts to slide. Other types of earth vibrations, even man-made vibrations like dynamite blasting and those types of things, can cause mass wasting. As we've already said, increased water in the soil can cause mass wasting. Increased weight of the soil with water or other things, like, for example, when they build houses and buildings on the sides of mountains and hills, they can encourage mass wasting because you're adding all that foundation and building material to the weight of that slope. A change in vegetation can trigger mass wasting. For example, if all the vegetation is stripped from a slope, that can encourage mass wasting. And of course, the undercutting of a slope, cutting material off the bottom of a slope, can encourage material on top of the slope to slide down. So let's talk about the types of mass wasting. And by the way, I know I go through this stuff quickly, but you can always pause, rewind, go back, and hear it again, okay? Types of mass wasting. First, there are falls. Falls are just rapid movements of earth material. They occur on very steep slopes, often vertical slopes like cliffs. There's different types. The two major types of falls are rock falls, where rocks fall down a vertical slope typically, and avalanches, where earth material moves down very steep slopes, maybe not vertical, but very steep. We oftentimes associate avalanches with snow, but avalanches can also be a rock material as well. Here is a picture of a rock fall. We've all probably seen something like this at some point in our lives. Another type of mass wasting is a landslide. This is a movement of earth material, typically down a gentler slope. It's still maybe a steeper slope, but not vertical or near vertical like with the falls. Because landslides are not vertical slopes or very, very near vertical slopes, then their movement's often slower. It doesn't mean it's slow, but it's slower. Two subtypes are landslides and slumps. Landslides are an overarching term for the movement of coherent earth material down slope along a plane. And slumps are when the earth material moves down slope, but it rotates along a curvature, a foundational curvature plane. Curved plane, which is contradiction of terms, but you'll see what I mean in a minute. So this is a landslide, general terms. See that kind of uniform earth material just slides down slope and slid into this poor little town. It looks like it covered 2 or 3 houses there. But that's a typical landslide. And this is a drawing or a sketch of a slump. Now notice, if you see at the bottom right-hand side of the diagram, it says surface of rupture. That's curved surface of rupture. That's a slump. Because the material in it, the head material that you see up there, the brown area labeled head, that material started top at the crown, right? And it slid down and rotated towards the bottom or the foot of the slump. Okay? So in a landslide, the surface is generally planar, which this one may or may not be planar, but whereas in a slump, there's a definite curvature to the surface. Another type of mass wasting is what we call a flow. Now, a flow is different because now we're mixing water with earth material that flows down slope. These flows can be fast or they can be slow. It just depends. There's different types. There are mud flows. These are small particles. Sand-sized particles are smaller that are mixed with large amounts of water, and they flow down really what look like stream channels, right? They flow very, very fast typically. Debris flows are very similar to mud flows, but they're made up of larger materials, sand-sized or larger, that mix with excessive amounts of water, just like in a mud flow. And these, again, can be fast or slow moving. Earth flows, when the flow of earth material happens under a substantial layer of sod. This is kind of an odd one. And I wish I could draw this one out for you, but I'm going to encourage you to watch a video at the end of this, and if you do, they'll show you what these look like. But yeah, it's like you have a layer of sod on the slope, but under that layer is some material that wants to slide, and so it slides under that sod, but the sod doesn't slide; it stays in place. So it's like this confining layer, and underneath the material slides. And what that results in is kind of a lumpy surface to the sod. The sod is intact, but it's kind of lumpy because the material under it is moving. Then there is solifluction. This is like an earth flow, but it occurs when ice melts under the sod and saturates the earth material, which then flows under the sod. So solifluction and earth flows are very much related to one another. And then there's creep. The creep is a very slow movement of earth material down slope, and it's typically caused by the freeze-thaw dynamics. Let me show you what I mean by that. Well, here's a debris flow. I know this looks like the same picture as before, but you'll notice that the material has slid more into the city than the last picture, because after the landslide, then rain came along and caused a debris flow that flowed even further into the town. Okay, so this is creep. Notice that if you've ever noticed in the winter time, when the ground freezes and it's wet, you'll notice that there's that raised surface, like the frost, the water, when it freezes in the top of the soil, kind of raises the earth material, the sod, up into the air, giving it that kind of like paper mache kind of look to the surface. I don't know if you know what I'm talking about. If you do, you'll notice that that's because the water molecules expand when they freeze, and they lift that material up into the air. When it thaws later, those particles are just dropped back down in the soil. However, if that process occurs on a slope, here's what's going to happen. You're going to be, those little black arrows there are indicating soil that's lifted up during a freezing event. And then when it's dropped back down, it's going to be dropped back down vertically. So that little piece of material is going to move down slope ever so slightly. Over many, many thousands, hundreds of thousands of freeze-thaw events in a piece of soil's history, it will slowly move down slope. Isn't that cool? What are some physical evidences of slope instability? Like if I look at a slope, how do I know that maybe it's unstable? First of all, I may see cracks in the soil. If I see that, that's a dead giveaway. Maybe evidence of past events. Maybe you see slump, right? Maybe you see a curved surface and slump, escarpments and that type of thing. Maybe you see tilted trees or poles or other structures that indicate that the soil has moved and tilted them. Or maybe you see undercutting. In other words, materials being undercut, moved away, and causing unstable slopes. So we want to stabilize slopes sometimes, oftentimes. So how do we do that? One is called water diversion. We can divert water so it doesn't saturate a soil and therefore make it unstable by creating diversion ditches. So actually the water never gets to the soil. Or if the water does get in the soil, we can create drains in the soil that drain that water off. So water diversion is one way to stabilize a slope. Benching is another way. That is cutting terraces into a slope so that you take away that long, steep slope by creating benches in it. Gabions are wire baskets filled with rock. I'll show you some pictures of these things in a second. And those wire baskets with rocks in them can help hold back material and stabilize the slope. Retaining walls, which if you've ever driven down Ward's Road past the mall, you notice that hotel that sits right there at the mall entrance that has a huge retaining wall in front of it. And then, of course, we talked about this earlier, vegetation. This is what gabions look like. The reason those rock piles look like steps is because those rocks are actually in chicken wire cages. So, and here is a video that I want to encourage you to watch. So copy down this URL. I'll try to put it in as a recommended thing in Canvas for you, but so you can just click on it. But if you can't click on it for some reason, just copy this link down and go to that video and watch that video. Now, I can't tell you have to watch it because I don't own the video, but I would encourage you to watch it. I think it'll allow some of these things to come to life for you. But I think mass wasting is pretty easy to understand because it's just very simply movement of material down slope. How does that happen, and how can we stop it? That's really what we're talking about here in this lecture and in your chapter on mass wasting. So don't forget to read that chapter. Don't forget to watch this video. If you've gotten this far, you've watched it, and just study and try to understand this material as best you can. Watch this video and then email me with any questions or concerns that you have. I'm here for you. And I know we had a problem with one of our labs recently. Just, if we have a problem like this, because we're trying to do this online thing on the fly, if we have a problem with something, don't worry about it. I'll take that into consideration. I'm not going to hold you accountable for something that goes wrong with a piece of technology. We'll work through it. It's not a big deal. Hey, appreciate each one of you. Have a great week. Again, call me, text me, write me, email me if you need me for anything. I'm here for you. All right? Talk to you soon.